All right, so as Andreas said, the paper is called Non-additive Axiologies in Large Worlds, and it's joint work with Terry Thomas, also at GPI. As I think Andreas mentioned, at GPI, the sort of central focus of our research over the last couple of years has been on this idea that people have come to call long-termism, which is roughly the idea that what we ought to do in most choice situations, or most of the most important choice situations, is primarily determined by the potential effects that our actions have on the far future, hundreds or thousands or even millions of years from now. And the sort of central argument for long-termism, if you sort of step back and squint, is what you might call an argument from astronomical scale, where those arguments sort of schematically have the following form. Because there are far more value-bearing entities, for instance, welfare subjects, who are affected by A than who are affected by B, we can make a much bigger difference to the overall value of the world by focusing on A rather than focusing on B. So in the case of long-termism, A is something like the long-term trajectory of humanity, or maybe more narrowly, the survival of human-originating civilization. And B is various things that we can do to make the world a better place in the short term, for instance, improving the welfare of farmed animals, say. So to get a sort of sense of the scales involved, for instance, Nick Bostrom in his 2013 paper on existential risks estimates that if we manage to settle a significant portion of the accessible universe, our civilization could eventually support more than 10 to the 32 human lives, or actually something like 10 to the 52 if we use simulations rather than biological human beings. And with numbers that large, the thought is sort of even very tiny changes either to the welfare of all those future people or to the probability that they exist in the first place could be vastly more important than anything that we can do in the near term. So these kinds of arguments are straightforward if we accept what we'll call an additively separable axiology. And we'll say precisely what that means in a little bit, but roughly for now, an axiology is additively separable if it treats the value of a world as the sum of values that are contributed by each value-bearing entity in that world. And if you accept an axiology like that, where you can think of the value of a world as such a sum, then it's sort of natural that things that affect a much larger number of individuals or welfare subjects are more important, because the impact that you have on the world just scales linearly, all else being equal, with the number of value-bearing entities or welfare subjects or whatever that you can affect. But if you accept an axiology that isn't additively separable, then things can be a lot less straightforward. So to start with a sort of simple stylized example, suppose that there are 10 to the 10th or 10 billion existing people. All of them have welfare 1, and we have 3 options. We can either leave things unchanged, or we can improve all of the existing people from welfare 1 to welfare 2, or we can create 10 to the 32 new people with welfare 1.5, while leaving the existing people all at welfare 1. Now, the sort of distinction here isn't necessarily that additive axiologies will tell you to choose O3 and non-additive axiologies will tell you to choose O2. So for instance, if you accepted a critical level view, which we'll introduce in a little bit, that's additively separable, and it would say actually O3 is really, really bad. But the sort of crucial difference here, and the reason, or at least one reason why the sort of additive separability marks a sort of important dividing line in axiology, is that an additive axiology like total utilitarianism, for instance, will say that if O3 is an improvement over the status quo, over O1, then it's a really big improvement. Or it's almost certainly a really big improvement. Makes a much bigger difference to the world for better or worse than O2 does. Whereas non-additive axiologies like average utilitarianism, for instance, might agree that option 3 is an improvement over the status quo. So in this case, we raise the average welfare of everybody in the universe from roughly 1 to roughly 1.5 if we choose O3, but see it as a smaller improvement than O2, because if we did O2, we could improve the average welfare to 2. So the point is that non-additive axiologies, like in this case average utilitarianism, needn't accept the claim that actions that affect a larger number of welfare subjects have a bigger impact on the overall value of the world, for better or worse. Okay, but so the central idea in our paper is that under certain circumstances, non-additive axiologies come to agree pretty closely with some counterpart additive axiology. And therefore, among other things, that these arguments from astronomical scale that go through on additive axiologies can be made to go through on non-additive axiologies as well under those circumstances. So the circumstances we have in mind are the existence of a large, what we'll call background population of welfare subjects who are unaffected by our choices. So we're imagining a situation where there's some part of the world that we can affect, and that's sort of effectively a choice between two possible subpopulations, X and Y, but then there's some pre-existing population Z that we can't affect. And so our choice isn't just between X and Y, it's between the combination of X and Z, right, versus the combination of Y and Z. So to give just a sort of illustration of what we have in mind when we talk about a background population, what this Z is, it can include things like, for instance, past human beings or past non-human welfare subjects, distant aliens in faraway galaxies, or also just present and future welfare subjects who are unaffected by our present choice. So there's some part of the world that we affect, but what we're interested in is the value of the world as a whole, and the world as a whole contains all of these individuals that we might not affect in a given choice situation. So just to give a sort of initial flavor of what these convergence results are going to look like, and we'll generalize quite a bit in the next couple of sections. If you have a very large background population with average welfare of 0, say you have 10 to the 100th individuals who all have welfare 0, and then you're choosing between two populations, X and Y, that are much smaller than that, it's going to turn out that average utilitarianism is going to tell you to choose the subpopulation, either X or Y, that has greater total welfare, because that will do the most to increase the average welfare of the population as a whole, given that you have this sort of very large pre-existing background population. So we're going to present some results like this, and then we're going to argue that the real-world background population, the population that we should treat as background for purposes of our actual choices, is large enough that these limit results are, or at least can be, practically significant. That may have a number of practical implications, but the one we'll focus on is that the case for long-termism and maybe in particular for things like existential risk mitigation from the astronomical scale of the far future can succeed even if you reject additive separability as a sort of assumption about axiology. Okay, so just to give a quick roadmap of where we're going, we'll do some formal setup, introduce some concepts and notation. Then I'll present the results and try to sort of move relatively quickly through that. We'll see there's sort of two categories of non-additive axiologies that we want to cover. One is average utilitarianism and these variable value views that are sort of asymptotically averagist in large population contexts. And then we want to talk about egalitarianism, egalitarian axiologies. Then I'll talk about the size of the real world background population, basically argue it's large enough that it looks at least pretty plausible that these limit results are practically significant. I'll consider two objections, which are basically objections to my arguments about the size of the background population. And then we'll look at some practical and theoretical implications, including but not limited to this point about arguments from astronomical scale. Okay, so setup first. A population or a world, as I think I'll sometimes say, is just a bunch of individuals who each have some level of welfare. And we'll assume, to simplify things for purposes of the talk, that the welfare levels can be represented as real numbers. So we have a set W, which is a subset of the reals, which represent the possible levels of welfare that individuals can have. In the paper, we make this a little bit more abstract, but it's a useful simplification to just assume real valued welfare levels. A population, then, is some non-zero finitely supported function from the set W of possible welfare levels to the non-negative integers that just tells you in that population how many individuals are there at each welfare level. So if population X, if X of 2 equals 10, that means that there are 10 individuals in population X who have welfare 2. It'll be important for our purposes to be able to talk about the combination of two populations, particularly combining some foreground population that you have the ability to bring about with a background population. So we can define that as follows. X plus Y is the combination of populations X and Y. And we just define that as for every welfare level W, X plus Y has a number of people at welfare W, which is equal to the sum of the number of people at W in X and in Y. A couple other bits of notation that will be useful. The size of a population we can just denote as follows, and that's defined in the intuitive way, the sum over all the welfare levels of the number of people at that welfare level. The total welfare will denote like this, TOT, and that's just the sum over all the welfare levels of the number of people at that welfare level times the real number that represents that welfare level. And then average welfare, which we denote with this like overline type thing, which is total welfare divided by population size. Okay, so that's some formalism for talking about populations. We also want to talk about axiologies, which are evaluative theories of how good one population is relative to another. So we'll understand an axiology A as a strict partial order, in other words, a transitive and irreflexive relation on the set of all possible populations, where this, X successor sub A Y means that population X is better than population Y according to the axiology A. And all of the axiologies that we consider in this paper can be represented by value functions, where what that means is the value function V sub A, for it to represent the axiology A, means that X is better than Y according to axiology A, if and only if the real number that it's assigned by the value function is greater. Okay, so as I said, the sort of crucial dividing line in axiology that we're interested in is between axiologies that are additively separable and ones that aren't. But actually there are sort of two closely related concepts here, and we're sometimes going to want to focus on one, sometimes the other. So we'll start with the sort of ordinal separability notion, and then we'll define the stronger property of additive separability. So an axiology A is separable if and only if for any populations X, Y, and Z, X plus Y is better than, or X plus Z rather, is better than Y plus Z according to that axiology. I'm sorry, there should be a subscript A there, if and only if X is better than Y according to that axiology. So the sort of crucial implication of separability in this sense is that if you're given a choice between populations X and Y in the presence of a background population Z, a separable axiology allows you to ignore the background population. You don't need to know anything about it other than it's going to be the same whatever you choose, versus a non-separable axiology, the features of the background population can matter. Whether you ought to choose X plus Z or Y plus Z can depend on the features of Z. Okay, so as I say, there's this stronger property that we're going to be somewhat more sort of focused on, which is additive separability. We'll say that axiology A is additively separable, or just additive for short, if and only if there's some function that maps the possible welfare levels to the real numbers, such that A can be represented by a value function of the following form, where we just sum up over all the welfare levels, the number of individuals at that welfare level in population X times f of W, where, remember, the welfare levels are real numbers we're assuming, and f is just some function that maps, in this case, real numbers to real numbers. So that means we can treat the overall value of a population as a sum, but not necessarily just the sum of welfare levels. We apply some transformation to the welfare levels. So separability and additive separability or additivity are pretty closely related. And all the axiologies we're going to consider here satisfy one if and only if they satisfy the other. But they are distinct properties. Additivity is a stronger requirement. So, it's sort of worth bearing in mind that there is a gap there. but most sort of axiologies that have been explored in the literature do satisfy one if and only if they satisfy the other. Okay, so to illustrate what it means or what an additive axiology looks like, and also to sort of set up some of the additive axiologies to which we're going to see various non-additive axiologies sort of converging in the presence of large background populations, we'll introduce three kinds of additive axiology in increasing order of generality. So the simplest, which we've already mentioned, is total utilitarianism, which just says that the value of a population X is the total welfare in X, which we can also express as average welfare times population size. Generalizing a bit from that, we have critical level utilitarianism, which says basically there's some critical level C, which is usually, but not necessarily, taken to be positive, greater than 0, such that adding an additional person to the population is only a good thing if they are at above welfare level C. So in other words, for every person they add, every person we add to the population, rather than just adding their welfare to the overall value of the world, we add their welfare, but then we subtract this critical level threshold C as a kind of penalty term for each additional person. And then finally, the sort of next broader category, you know, and it's worth noting this is sort of an idiosyncrasy of the way that we define things, that critical level utilitarianism will be a special case of prioritarianism. But prioritarianism, in the sense that we understand it, will be any axiology that can be expressed by the following sort of value function, where notice this looks just exactly like our definition of additive separability in general, except that we add the stipulation that this function that tells us how good it is to have an individual at a particular welfare level is strictly increasing. So more welfare is always better, and weakly concave. So if someone's better off, then the marginal value of an additional improvement to their welfare decreases, or at least it doesn't increase. Okay. So finally, remember the sort of the claim that we're going to, well, establish in a number of cases is that some non-additive axiology in the presence of a large enough background population is going to tell you to add subpopulation X rather than subpopulation Y, if and only if X is better than Y according to some counterpart additive axiology. And that means we can sort of decide what to do, even according to our non-additive axiology, by applying an additive axiology. So we want to sort of define that carefully so you know exactly what these results are saying. So say that axiology A converges to another axiology A prime relative to background populations of type T, if and only if, for any populations X and Y, if Z is a sufficiently large population of type T, then if X plus Z is better than Y plus C according to this axiology A prime that we're converging with, right, then that means that X plus Z is better than Y plus C according to axiology A. Now note that we have to sort of include this restriction to background populations of a type T, and we'll see what that means going forward. But for instance, we may need to, as we consider larger and larger background populations, hold fixed, for instance, the average welfare level in the background population or the distribution of welfare levels in the background population to get you know, a defined limit. Now note that if this axiology that we're converging to, A prime, is additive, which in all the cases we're interested in, it will be, this thing that we say here is equivalent to the simpler thing that if X is better than Y according to the axiology A prime, the additive axiology that we're converging to, then that means X plus Z is better than Y plus C according to axiology A. So that means if we want to figure out what to do according to axiology A, we can just look at these two kind of foreground populations, X and Y, and evaluate them according to A prime. Okay. And yeah, with adding the caveat that we have to know that Z is a large enough background population, and we have to know that it's a background population of the right type. Okay, so let's now present some results. So starting with average utilitarianism, sort of the simplest case, right? Average utilitarianism says that the value of a population is just the average welfare level in that population. And kind of informally, the limit result that we find here is that as the size of the background population goes to infinity, average utilitarianism converges with or asymptotically agrees with a critical level theory, where the critical level is the average welfare level in the background population. More specifically, we can in fact say in the case of average utilitarianism that average utilitarianism is going to agree with critical level utilitarianism whenever the size of the background population exceeds this threshold here. So interestingly, right, in this case, we can say not just this happens in the limit, but we can say sort of when we've reached that limit case with respect to a particular choice situation, right? So note that this threshold depends on properties of X and Y. Now, we won't be able to say that for some of the axiologies that we run into later, for instance, the variable value axiologies we talked about on the next slide. But in this particular case, we can sort of give a threshold. So again, right, the sort of interesting implication here is if you're an average utilitarian and you know that there's a large background population that has average welfare level C, then to a good approximation, you can decide what to do by just applying a critical level axiology with critical level C to the sort of two subpopulations that you're choosing between. Okay, so closely related to average utilitarianism are these views that are called variable value, introduced by Thomas Herka in the 80s. And these come in sort of two flavors, roughly increasing order of generality, more or less. So variable value 1 says, well, look, where total utilitarianism evaluates a population by average welfare times population size, a variable value axiology of this first kind applies a transformation to population size. This transformation Z, which is strictly increasing, strictly concave, and bounded above. So what that means is that if we have, for instance, a population with positive average welfare, then making that population bigger is good. It makes things better. But the marginal value of adding more happy people to the population decreases, and decreases to some upper limit. So variable value 1 basically behaves like total utilitarianism for small populations, where we can treat G as sort of effectively linear, and then behaves like average utilitarianism for large populations where we're close to that horizontal asymptote. And then there's a variable value 2, where we just also apply another transformation F to average welfare. And the stipulation there is that F is differentiable and also strictly increasing. So greater average welfare is better. And because both variable value 1 and variable value 2 are sort of averagest in the large population limit, that's sort of supposed to be part of their attraction, it's a little bit unsurprising that in the large background population limit, which is a kind of large population limit, they do just the same thing that average utilitarianism does, namely they converge with a critical level theory, where the critical level is the average welfare level in the background population. Now note, as I said on the last slide, in the case of averagism, we can sort of say where that convergence happens, or we can say at what point it's guaranteed that we can just evaluate populations X and Y by applying the critical level theory. Here, we can't do that. The easy way to see that is these variable value theories can be sort of arbitrarily close to totalism for an arbitrarily long time. So there's no threshold beyond which they have to sort of start acting at all like averagism, or hence at all like the critical level theory. Okay, so that covers averagism and variable value views. The second category of non-additive axiology we want to talk about is egalitarianism. So egalitarians, of course, care about equality. They care about how equally welfare is distributed in the population as a whole. And this naturally motivates violations of separability, and as a result, violations of additivity, because the impact that some subpopulation has on equality in the population as a whole depends on what the welfare distribution is in the rest of the population. Now, unfortunately, there's, I mean, a lot has been said about egalitarianism in various contexts, but mostly in fixed population contexts. And so we're a little bit in the dark as to what the most plausible variable population egalitarian axiologies are, but there seem to be sort of two major choice points. So one is between totalist, or more broadly, what we might call totalish versions of egalitarianism, and averagist or average-ish versions of egalitarianism, where roughly the thought is, you know, a totalish theory is going to say, well, if the existing population is good, then adding more and more copies of that existing population makes things better without limit, and vice versa if the existing population is bad, and average-ish theories will deny that. And then there's another choice between what we might call two-factor or pluralistic egalitarian theories, which basically you know, have some measure of inequality and treat that as a kind of penalty term, where you look at like the total or the average welfare in a population and then subtract the penalty for how unequal the distribution of welfare is in that population, versus rank discounting views, where what they do is sort of rank everybody in the population from worst off to best off, and they just give less weight to your welfare the higher your rank is. And it turns out these two ways of sort of representing egalitarian concerns are extensionally equivalent in a fixed population context. Anything that you can represent as a two-factor egalitarian view, you can also represent as a rank discounting view, but they come apart. They're no longer equivalent in that way in variable population contexts. Okay, so we're going to kind of look at all four cells in this kind of 2x2 matrix of possible egalitarian views, although we're not going to be able to cover every possible view, even within these categories. And as we'll see, the sort of average-ish rank discounting view provides a sort of interesting exception to our general results. But starting first with these two-factor views. So to simplify, let's consider just these two kind of simple categories of views, which we can call totalist two-factor egalitarianism and averagist two-factor egalitarianism. So a totalist two-factor egalitarian view says that the value of a population is given by the total welfare in that population plus this inequality term, where this is some negative like penalty for how unequal the distribution of welfare in X is, times the population size in X. So the badness of inequality scales with the size of the population. And I, as I've said, is an inequality measure. And then we can define a sort of averagist two-factor egalitarian view that measures the value of a population by average welfare plus the inequality penalty term, not multiplied by population size. Okay, so to give a convergence result for these kinds of views, remember when we were talking about averagism and variable value views, we had to hold fixed the average welfare in the background population. So we consider larger and larger background populations with the same average welfare. Here, because egalitarian views are sensitive not just to the average welfare in a population, but to the whole, potentially the whole distribution, we have to hold the distribution fixed. So let's say that the distribution of a population X is just this function that gives the proportion for any welfare level W, gives the proportion of the population that has at most welfare W. So it's like a cumulative distribution function for welfare in population X. Okay, so then we can give this general result, our theorem 3, that says consider value functions of either of these forms, either the totalist or the averagist two-factor egalitarian value functions. And just assume that this inequality function I is a differentiable function of the distribution of X. So the sort of substantive assumption there is that we can, tell how unequal a population is just by looking at the distribution of welfare levels. Then an axiology A that's represented by any such value function, V, will converge to an additive axiology with respect to background populations with any given distribution. So what that means is we specify the distribution of welfare in the background population, and then we consider larger and larger background populations that have that same distribution, and in that limit, any totalist or averagist two-factor egalitarian view will converge with some additively separable axiology. But on top of that, suppose that the two-factor egalitarian view we're considering satisfies the following two principles. First, it satisfies Pareto, so improving the welfare of a given individual makes things better, all else being equal. And second, that Pigou-Dalton transfers are weak improvements, where that means taking some welfare from a better off person, giving it to a less well-off person, but only so much that the first person is still better off than the second person after the transfer. So we also assume that those are at least weak improvements, meaning that they don't make things worse. And that seems like a characteristic commitment of egalitarianism. So if our egalitarian axiology satisfies those two conditions, then the additive axiology that it converges to will be a form of prioritarianism. And you can see that sort of makes sense, right? So prioritarianism adds these two extra constraints to just additive separability in general. One, that the priority weighting function has to be increasing, so greater welfare is always better, and that corresponds to the Pareto principle here. And the second is that the priority, the function is concave, so the marginal value of additional improvements to welfare decreases as an individual's absolute welfare level increases, right? And that corresponds to the desirability of Pigou-Dalton transfers. Okay. So let's illustrate that just with two examples of views of this kind, just to see that, well, sort of interestingly, when we specify a particular version of egalitarianism, we can say not just the convergence happens in general, but we can say what the priority weighting function is for the prioritarian theory that we converge to in the limit. So here's a totalist version of two-factor egalitarianism that uses as the measure of inequality the mean absolute difference of welfare levels. So the average difference basically between the welfares of any two individuals that you randomly sample from the population. And then just weights that by this term alpha between 0 and 1/2, which is what makes this axiology Paretian. If we're greater than 1/2, then we would sometimes prefer to level down to reduce an individual's welfare to increase equality. And we can say that if we have a background population with some fixed welfare distribution D, then in the limit, as that background population gets bigger and bigger, then this MDT axiology will converge with a version of prioritarianism where the priority weighting function is this, which I won't bother to read out. The sort of the interesting thing here is just that we can say what the priority weighting function is. And then to look at an example of an averagist egalitarian view, consider this, what we'll call QAM, which just measures the value of a population by the quasi-arithmetic mean of its welfare levels, which is defined as follows. And here, the measure of inequality that we're using implicitly is just average welfare minus quasi-arithmetic mean. And you can think of this as sort of roughly an averagist version of prioritarianism. Yeah, here again, well, sort of unsurprisingly, we've seen that averagism converges, and we've seen that egalitarian views converge. So again, this QAA view is going to converge with prioritarianism given a large enough background population with a fixed distribution D. And again, we can say what the priority weighting function will be. Okay, so that leaves the sort of second big category of egalitarian or at least sort of allegedly egalitarian views. There's some dispute over whether we should really think of this as a kind of egalitarianism. But rank discounting, as we've said, the way that this works is you order all the individuals in a population from worst off to best off. So this X sub K denotes the welfare of the kth worst off welfare subject in the population X. And then we have some function that tells us how much we care about the welfare of the kth worst off individual, where F is positive, so we always care to some extent, but it's decreasing. So the better off you are, the less we care about exactly how well off you are. And here again, we have to add a little bit of additional restriction to describe our convergence result that we do get here. So we have to say, well, so say that an axiology A converges to A prime on a set of populations X relative to background populations of type T, if and only if for any populations X and Y in S. Blah, 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 the sort of same conditions we gave before. The point is just here, we restrict ourselves to choosing between foreground populations X and Y that are in some specified set. And we'll see on the next slide why we need to do that. Okay, so the choice point here that corresponds to whether rank discounted utilitarianism is sort of in a totalist spirit or an averagist spirit, is whether this rank discounting function f or rank weighting function f decreases to 0 or is bounded above 0. So a bounded rank discounted utilitarian view, well, we just take this definition of rank discounting in general, but then we stipulate that the function f that tells you how much you care about the well-being of the kth worst off individual is eventually convex. And has an asymptote L that's greater than 0. So in other words, the weight that you give to better off individuals decreases, but it never decreases below some positive threshold L. And now we need to stipulate the class of populations X and Y within which we get a convergence result. So say that a population X is moderate with respect to a distribution D, if the lowest welfare level in X is still higher than some welfare level in D. So this means for our purposes, you're choosing between populations X and Y in the presence of a background population Z. The situation where our result is going to apply is where there are some individuals in that background distribution D who are worse off than anybody in the populations X and Y that you're choosing between. So under that condition, we can say that bounded rank discounted utilitarianism will converge with total utilitarianism, given a large enough background population with a fixed distribution D. Now, okay, so the one case that we have left is unfortunately the trickiest, which is why I've left it for last. So the sort of average-ish version of rank discounting, well, there are various ways this could go, but one version of this view that exists in the literature is what we'll call geometric rank discounted utilitarianism, which is defended by Aschheim and Zuber in 2014. And their rank weighting function is just this. You have some constant beta in the open interval 0, 1, and you just exponentiate it to the power of k, where k is the welfare rank. So as you consider better and better off individuals, you care exponentially or geometrically less and less about them. Now, sort of broadly, what happens here is that under the same circumstances we described on the last slide, where you have a background population with distribution D, and you're choosing between two populations X and Y that are moderate with respect to D, meaning that the worst off individual in X or Y is still better off than the worst off individual in background population Z. GRD is eventually going to converge to what we might call a critical level Lexeman theory, which means that it cares lexically more about the welfare of less well-off people. And also there's some critical level such that adding someone to the world below that critical level makes things worse, where the critical level is either 0 or it's the maximum welfare in the background population, whichever is greater. So I haven't given this as a formal result because it would require us to introduce some new notation. Happy to talk about this more in Q&A. The kind of interesting thing here is this critical level Lexeman view is not additive in our sense because it can't be represented by a sort of real valued function or additive function, but it is additive in a broader sense if we allow axiologies to be represented by, by vector valued rather than real valued value functions. So it's in a sense a sort of limiting case of this phenomenon that non-additive axiologies converge to additive axiologies in large background population limit. Okay, So we've shown that various non-additive axiologies will converge with some kind of counterpart additive axiology given a large enough background population. So the natural next question is, how large is the actual background population in real-world choice situations? It's sort of a little bit unclear, like, what we want to say about this question or what would count as a satisfactory answer, because, as I said, for instance, in the case of average utilitarianism, we can say something pretty concrete about how big the background population has to be for the limit results to kind of kick in. In the case of other axiologies, we sort of can't as much. But what I'm going to say anyway, or argue, is that the background population is at least significantly larger than the present human population, and that this at least sort of suggests that our limit results are relevant for many practical purposes. So to start by just giving some numbers, as we know, the number of present humans is roughly 7 billion, i.e. 7 times 10 to the 9th. The best, or at least the most widely cited, estimate of the number of human beings who have ever lived is about 10 to the 11th, so a little bit more than 1 order of magnitude larger. But of course, humans aren't the only welfare subjects. So we might ask, for instance, about the number of mammals in the world. Now, what we know about this is really hazy and uncertain to at least sort of a couple orders of magnitude. Brian Tomasik has this nice write-up that I've cited here that summarizes what we do know and gives a good sense of sort of the limits of our knowledge. But it seems reasonably safe to say that the number of presently existing mammals is at least on the order of 10 to the 11th. And if we, care about the world as a whole and not just, the people who presently exist, then we also want to know about, past individuals. We talked about past humans, the number of past mammals, doing some pretty conservative back of the envelope math, just counting since the KPG extinction event 66 million years ago and making conservative assumptions about birth and death rates, we get that there are at least 6.6 times 10 to the 18th mammals in the kind of timeless population. And then for vertebrates more generally, so including reptiles and fish, for instance, it looks like there are at least 10 to the 13th of those alive now, and probably have been at least 5 times 10 to the 22nd since the Cambrian explosion. And the point to notice here is just all of these are significantly larger to, 1 or up to, 10 or 13 orders of magnitude larger than the present human population. Now, as we saw, it's not just the size of the background population that matters. The practical upshots of these limit results, if and when they do kick in, depends on the average welfare in the background population and also on the distribution of welfare. And unfortunately, it's just sort of hard to say very much here. There are 2 hypotheses, I think, that sort of naturally suggest themselves. One is that the background population consists mainly of small animals and has an average welfare that's close to 0. Another hypothesis is that the background population mainly consists of members of advanced alien civilizations. So if you think, for instance, that a biosphere that doesn't produce a spacefaring civilization is going to produce maybe, say, using the numbers here, maybe 10 to the 23, 10 to the 24 individuals in its lifetime, but a spacefaring civilization can produce 10 to the 30 or 40 or 50 individuals. Well, it doesn't take a lot of spacefaring civilizations for them to dominate the overall population. And then if that's right, given the limits of our present knowledge, all bets are off with respect to average welfare in the background population, because who knows what those advanced alien civilizations are like. And I think more generally, on either hypothesis, it's pretty hard to say much about the distribution of welfare in the background population, except that there do seem to be sort of non-trivial inequalities. So, pet dogs hopefully have pretty high welfare. Factory farmed layer hens seem to have pretty poor welfare. So there is, some breadth of distribution. But if anybody thinks we can sort of fruitfully say more here, I'd be very interested to hear about that. Okay, so I'm going to just very quickly talk about 2 objections, and yeah, kind of breezing through these in the interest of time, and then we could return to these in Q&A. So one objection is, look, for sort of practical or ethical purposes, why do we even care about the parts of the population we can't affect, what I've been calling the background population? Shouldn't we just focus on the part of the population we can affect? So one way to make this suggestion precise is with what Nick Bostrom calls a causal domain restriction, where you evaluate outcomes by just applying some axiology, your preferred axiology A, not to the world as a whole, but only to the part of the world that you can in principle affect, which presumably means your future light cone. So if we do that, then obviously a lot of the sort of background population goes away, namely all the past individuals, and presumably also aliens in sufficiently far away galaxies. So 3 reasons why we're sort of skeptical of this reply. First, it seems to give up a pretty core motivation for consequentialism, namely that we have some sort of non-derivative reason to make the world a better place, where that means make the world as a whole a better place. And it seems just harder to explain why we would have non-derivative reason to make our future light cones better places when that comes apart from making the world as a whole a better place, or when it involves making the world as a whole a worse place, according to your axiology. Secondly, when you combine a non-separable axiology with a causal domain restriction, you get these weird effects like diachronic inconsistency, where I know at time t, I'm going to be faced with a choice between adding population X or population Y to the overall population. And given what will be in my future light cone at that point, X will be preferable to Y. But from where I am now, Y looks like a better addition than X. And so I would want to constrain my choices. I would pay some price to prevent myself from choosing X in the future. And similarly, you can get conflicts between agents who share the same axiology. Herka gives one of these diachronic cases, by the way, in this 1982 paper, more average utilitarianisms. So all of this stuff just seems pretty weird, although maybe it's sort of a matter of taste, how bad you think those implications are. And then finally, maybe the most important thing is that it seems like even if we adopt a causal domain restriction, much of the population that's inside our future light cones can pretty plausibly be treated as background for purposes of most decisions. So most of the choices we make, even most of the ethically important choices, like where to donate money, for instance, only affect a small part of even the present human population or the present population of welfare subjects. And so it seems like the part of the population that we don't affect, even inside our future light cone, is going to be usually several orders of magnitude bigger than the part that we do affect, or at least that we can affect by these sort of short-termist interventions. Another response is, look, these large numbers that I gave for the size of the background population come from thinking about, for instance, mammals or vertebrates, where those populations are probably largely made up by, say, small mammals like rodents or by small fish. But even if you think that they count as welfare subjects, maybe you might think that they sort of in some sense count for less, and more specifically that they should make a different, smaller contribution to the size of a population as we measure it for axiological purposes. So we could apply these sort of axiological weights where, for instance, if we're average utilitarians, the way we calculate the size of the population, the thing that we divide total welfare by to get the average, is not just the number of individuals, but the sum of their axiological weights. So a couple of things to say here. Number one, in the paper, we actually try to do this in what we think is a fairly conservative way, where we only count mammals as welfare subjects, and we take mice as a proxy for all non-human mammals, and we discount both by lifespan and by cortical neuron count, and we still get a discounted population of past and present non-human animals that's at least 2.3 times 10 to the 13th, so still significantly larger than the present human population. Also, we already saw the past human population is fairly large. And again, there's this point that much of the present and near future human population can plausibly be treated as background for a lot of decision-making purposes. Okay, so all that is to say, there's at least a large enough population that it makes sense to treat as background that it's plausible to think that these limit results are practically significant for agents who accept non-additive axiologies. Now, we've been sort of struggling with how to make this point in an interestingly general way, and this is something where we could really use input if you can see a sort of good way of doing that. But just very simply for now, to give a sort of stylized example of these limit results in practice, let's return to that case that we started off with, where we imagine there were 10 to the 10th existing people. they all have welfare 1, and we can either leave things unchanged or improve all the existing people to welfare 2, or we can create 10 to the 32 new people with welfare 1.5. And remember, total utilitarianism in this case prefers option 3, whereas average utilitarianism prefers option 2. But now if we assume that there's a background population of 10 to the 13th, and using here, one of the more conservative numbers for what the size of the real world background population might be, and then all we have to assume is that the average welfare of welfare subjects within that background population is anything non-trivially less than 1.5. Then it's going to turn out that AU now agrees with total utilitarianism and prefers O3. And in fact, in this case, we can say by extension, so do VV1, VV2, and various averagist flavored egalitarian theories, which wouldn't have before. So we do get, at least in this sort of narrow stylized case, a pretty conservative assumption about the size of the background population is enough to make our limit results sort of practically impactful here, and to sort of rescue the conclusion that the option that affects the sort of astronomically larger number of people is the more important thing, makes a larger difference to the overall value of the world. And yeah, just to reinforce that point, right, here I made the assumption that average welfare is non-trivially less than 1.5. If we just assume it's non-trivially different than 1.5, either greater or less, the sort of more general conclusion we reach is that average utilitarianism and related theories will now agree that O3 makes a bigger difference to the overall value of the world, either for better or worse, than O2. Right, so we're at least sort of on the road to recovering these arguments from astronomical scale. Okay, let me very quickly mention 3 other conclusions that we talk about in the paper. And again, these would be good fodder for Q&A if people want to get into them more. One is, and this is a conclusion that's already been noted in independent work by Mark Budolson and Dean Spears, that the sort of presence of background populations makes it harder for various axiologies to avoid this kind of generalization of Parfit's repugnant conclusion, where there's some pre-existing background population, and the question is it better to add a moderate number of people with very high welfare or an enormous number of people with lives barely worth living? And the sort of repugnant addition problem, in the presence of large background populations, a very wide range of axiologies that can avoid the sort of original repugnant conclusion will endorse repugnant addition. Second point, we think that these results have some implications for infinite ethics. So infinite ethics is sort of the task of evaluating and saying, what agents should do in the context of infinite worlds with infinitely many welfare subjects. And there's a pretty large literature on this, but that literature sort of gives a lot of recipes for generalizing additive axiologies from finite to infinite populations, but has had very little to say so far about non-additive axiologies. And our results at least suggest a sort of partial way of generalizing non-additive axiologies to infinite worlds, namely when you're in an infinite world, but you can only affect a finite subpopulation, then you're effectively not just approaching, but in this limit that our limit results describe, right? There's an infinitely large background population. And so it seems like we can just replace non-additive axiologies with their additive limit theories. And we then have these sort of recipes from infinite ethics for generalizing those additive theories to the infinite context. Now, there's some problems here we have to be able to talk about, for instance, the average welfare in an infinite population and the distribution of welfare levels. And it's tricky to know how to do that, but there's at least a sort of pathway here that seems worth exploring. And then the final thing is that these results suggest the sort of fun possibility of manipulation. So suppose you have some average utilitarians over here and some total utilitarians over there. The total utilitarians would like the average utilitarians to act like total utilitarians. Well, one way they can make that happen is just by producing a very large number of welfare subjects with near zero welfare, e.g. breeding trillions and trillions of Etruscan shrews, which I gather are the smallest mammal on Earth. And by creating that very large population, that sort of background from the point of view of the averagists now have to act more and more like totalists. So how practically significant that is, we don't know, but maybe not very, but it at least seems sort of fun and interesting. Okay, so to recap, We found that when there's a large enough background population of welfare subjects that are unaffected by our choices, a range of non-additive axiologies can converge in practice with some additive axiology. I at least sort of made the argument that the real world background population is large enough that it's plausible that these results have some practical significance. And if they do, maybe the most important implication is that arguments from astronomical scale, and hence the case for long-termism, and maybe more particularly the case for existential risk mitigation, is less dependent on assumptions of additive separability than we might have thought. Now, there's a lot of questions that we haven't addressed in this area that I'd be very interested to see other people get into, or maybe we'll get into at some point. One, of course, is giving a sort of better characterization of what the real world background population is like, which I've only said a very little bit about. The other sort of big obvious thing is we haven't yet considered decisions under risk or uncertainty. And in particular, when you're making choices with a very large background population, but you're uncertain about the size or the welfare distribution in the background population, it's not at all clear how that would go. So that seems like another interesting topic for research if people want to take that up. So I'll leave it at that and look forward to your questions.